This lesson pertains to string of text that are encoded as ASCII. There are other ways to encode text which are not covered in this lesson. However, the principles that are taught in this lesson are equally valid in any case in which you are encoding text. In an earlier lesson, you learned about ASCII and the different ways that characters are encoded inside of your computer. In this lesson, we will look more closely at how text is stored in memory. First, remember that every ASCII character is encoded in exactly 8 bits. Remember that all the capital letters begin with 010, with the final 5 bits counting from 1 to 26 corresponding to that letter of the alphabet, and lowercase letters do the same, but begin with 011. Finally, you learned that numbers begin with 0011, and the final 4 bits will give you the actual number. If any of this is confusing to you, just watch the previous several videos and it should be clear to you. So at this point, you should have enough of an understanding to see how small strings of text are actually stored in memory. Let's take a look at an example of this. Alright, so here we have 3 bytes that we are imagining inside of your memory. So if you look at this, you will notice that each of them start with 0011. And if you recall, anything that starts with 0011 is potentially going to be a number as it is expressed in text, meaning not the actual quantity, but the way a number is represented as text or the way it is typed on the keyboard. So we can see that this value is 1, this value is 2, and this value is 3. So that means that this is the string of text 1, 2, 3. Now in this example I used a colon character just to make it easier to read so that you can see how the bytes are separated. Now let's imagine that I have some function that can print ASCII characters like the printf function, and I tell that function to start at the beginning of my sequence and then start printing. So first it's going to read this byte and it's going to print a 1, and then it's going to read this byte and print a 2, and then it's going to read this byte and print a 3. Now think about this for a moment. When I put the sequence of 3 bytes into memory corresponding to the characters 1, 2, 3, that sequence got placed in a specific location in memory. So let's imagine how this might look. Alright, so let's once again look at how the string of text 1, 2, 3 is encoded in memory. So this is the actual stream of 1s and 0s you would find in your memory for this exact string of text. So if we have our printf function and we start printing each character, what happens when we get to the end? Remember what I said earlier, that you cannot tell what something is just by looking at it because the same 1s and 0s could be anything. And inside of your memory, you don't have only these 3 bytes. Before this and after this, there's going to be more 1s and 0s in both directions. On the bottom here, I've illustrated this. So once again, we're looking at our string of text of 1, 2, 3, but now we have more strange 1s and 0s. Now, what are these? These 1s and 0s are whatever happens to be in memory after your string of text, which could be anything. So what you need to remember is that if you have a function like a printf function that is designed to print text, and it starts at the beginning and it prints 1 byte, then it prints the next, then it prints the next, how does it know when to stop? The answer is you have to tell it to stop by doing one of two things. You can either tell it to print a certain number of characters. You could have a function that is designed to print exactly 3 characters, and then it'll print the first one, the second one, and the third one, and then know to stop because it's printed 3 characters. But usually what you do is you add a terminating character at the end of the string. And usually the terminating character is a single byte of all zeros. So here, once again, we are looking at our string of text, which is 1, 2, 3. But now what we've done is at the end of our string of text, we have put a new byte that is all zeros. So if we have a function like the printf function, and we tell it to print that text, it's going to start at the beginning, and it's going to keep on printing until it runs into an all zero byte. Now, a byte that is set to all zeros has a special name. It's called null. So whenever you have a string of text that ends with a null character, then whatever comes after that doesn't matter, because your function will know to stop at that exact point. Now, it is very important for you to remember that whenever you have a string of text and you terminate it with a null character, then the size of your string of text is going to be whatever you had plus the null character. So in this case, our string of text is 1, 2, 3, 4 bytes in size. So here you might be wondering what happens if you have a string of text that does not end in a null and you try to print it. Well, have you ever had a situation where you saw really strange text printing to your screen with all kinds of strange symbols and weird characters? That happened because your computer started printing the binary sequences at the end of a string of text that was not properly terminated. What will basically happen is every character will be printed until an all zero character is found. Any sequence of 8 bits can be rendered as some character. And this includes many especially strange characters that have nothing to do with letters and numbers. Therefore, we must define some way that we can know where to stop printing characters. Now, I'm presenting this lesson in the context of text strings, but this same principle applies anytime you are processing data of any length. If you do not specify where to stop, you may just keep on processing the data. For example, just as it is possible to keep on printing sequences of 8 bits as though they were ASCII characters, it is also possible for a music playing program to start trying to play what it thinks is music, which turns out to be something entirely different. The result, of course, would be some strange music. So here you learn an important concept. You must always define a stopping point for any data. Always. There are 2 ways you can do this. Either you can predefine a set length, like in our earlier example with the string of text 1, 2, 3, we could choose to define a set length of 3 characters, and then we can tell a function to only print those 3 characters, and it would stop knowing that it's not supposed to go past that. Or we can define a character at the end of the string of text that means stop, which is usually done using the null character, which is 8 zeros, like you see. Effectively, what this means is that we can have a string of text as long as we want, but we have to remember to put a special all zeros byte at the end. Then we tell the function to stop when it reaches the all zeros byte. The technical term for this kind of string of text is a null-terminated string of text. We say null-terminated because null is the character that ends it or terminates it, and null is made of all zeros. So one more time, let's take a look at how the string of text 1, 2, 3 actually looks in memory. Now remember, on either side of this, there's going to be more ones and zeros that are whatever they happen to be. So somewhere in your memory, you're going to have the starting point where it's going to begin with 0011, 0001, which is the number 1 in text, followed by the number 2, followed by the number 3, and then a sequence of 8 zeros, which is the null character, which tells us that we are ending the string. And also, you should now have a good understanding of how a function such as printf knows when to stop. So remember, whenever you have data in a program, you must have a way to tell your program when to stop, because your program will not know just by looking at the ones and zeros where music ends and numbers begin, or where text ends and leftover data from a program you ran yesterday will be. So you need to always remember that.